Hello everyone and welcome. In this video we are talking about the engine in the new Koenigsegg Jesko. So this is a very crazy, very wild, super powerful new mega car that Koenigsegg has released. And in this video we're going to break down the engine, some of the different components. There's all kinds of clever engineering that Koenigsegg has done with this engine. So we will start off talking about the specifications and then work through some of the very cool, unique features of this engine and how it has changed from the Agera RS. So just like the Agera RS, it is powered by a 5-liter twin turbocharged V8 engine. And now it is producing 1,280 horsepower on pump gas on 91 octane US or 95 octane Europe, or 1,600 horsepower if it is running on E85. It is capable of producing 1,500 Newton meters of torque or 1,100 pound-feet. So we've just heard about Ram's new heavy-duty truck that has 1,000 pound-feet of torque. This has 1,100 pound-feet of torque and like 1,000 more horsepower than that Ram truck. So 1,600 horsepower, 1,000 Newton meters of torque from just 2,700 RPM, with that peak torque coming on at 5,100 RPM. That range of 1,000 Newton meter plus of torque from 2,700 to 6,170 RPM, and then revving all the way to 8,500 RPM thanks to a flat plane crankshaft, which we will get into later in the video. Now, Koenigsegg claims that this vehicle should be able to reach 300 miles per hour. I really hope we see a production car making this magical number. It'd be super cool to see. And also, this will likely be the very last purely internal combustion engine powered Koenigsegg. So the future will have hybrids, much like the Agera, and electric cars that Koenigsegg will be developing. This one being the last purely gasoline-based, ethanol-based engine that they will have within their vehicles. But they're going out with a bang. This is the most powerful internal combustion engine they have ever created, and Koenigsegg states that this is the most powerful homologated production internal combustion engine ever. Now, because they lead that statement with "we believe," legally it really has no meaning, but that doesn't matter. I don't know of another production engine which is globally street legal and globally meets emissions. So very cool. That's very hard to do when you're trying to create an engine that has 1,600 horsepower, but also meet all of the emission regulations of this planet to keep it nice and green and all that fun stuff. So first off, gasoline versus E85. It can run on either. So it has a flex fuel sensor. It's able to determine what fuel is going into those injectors, what's being injected into the engine. It reads that, sends that information to the ECU, which determines how much power it can make and adjusts things like timing, air-fuel ratio, boost accordingly. And so with gasoline, 91 octane in the US, 95 octane in Europe, those are the same octane rating, we just use different scales, it will make 1,280 horsepower. Using E85, which has a higher octane rating than pure gasoline does, so pure ethanol will be, well above 100 octane rating, and so that gives you some flexibility with what you can do with the engine. So they're able to create 1,600 horsepower running on E85, 85% ethanol. So by using ethanol, you have the benefit of that higher octane rating, and that gives you 3 variables that you can play around with to help make more power. So first of all, being timing. So you can advance the timing, meaning you fire that spark plug sooner without worrying about knock or damaging the engine. So you can have peak pressure occur at a more ideal time, and as a result, you can create more power. It also means that because you're less likely to run into knock issues, you can run more boost, and you also have more flexibility with your air-fuel ratio. So if you're having problems with knock, you're gonna have to run a really rich air-fuel mixture, which may not be ideal for power. By having a higher octane rating, you can choose that perfect air-fuel ratio and create the maximum amount of power possible. Now, if you're going to make a crazy amount of horsepower, 1,600 horsepower, well, you're going to need a ton of fuel. So the Koenigsegg Jesko is the first production car to have not 1, not 2, but 3 fuel injectors per cylinder. So plenty of fuel supplied there, and so you have the 2 within the intake runner here mounted on a traditional fuel rail, just like it's done with the Agera, and then you have an additional fuel injector added to the intake plenum before each runner for each individual cylinder. So you've got those 3 for each cylinder. Another reason for this, so we have the difference between E85 and gasoline. So E85 is less energy dense. So pure ethanol, 1.5 2.5 gallons of pure ethanol is the energy equivalent to 1 gallon of gasoline. So we need quite a bit more fuel in order to produce the same amount of power. And so that means we're dumping loads of fuel into this engine when we're running on E85 and we're creating 1600 horsepower. But there are other benefits to having this additional fuel injector as well. For example, by injecting sooner, it means that fuel has more time to mix with the air around it. So better aeration. And so, think about those scenarios where you want to be efficient. For example, when you're at low RPM and low load, where engines are traditionally quite inefficient, by having that better aeration, better air-fuel mixture, you're going to have more efficiency, more complete combustion. And that's also going to help with cold starts, giving that air, giving that fuel and air more time to mix before it reaches the engine and you have that power stroke occurring. So there are benefits for both a power standpoint. Obviously, you need loads of fuel, but also an efficiency standpoint, having that cooled, better mixed air from this injector that's injected into the plenum with plenty of time to mix before it enters into the cylinder. Now, as I mentioned, some of the changes which they made to this engine were not necessarily about power, but also about keeping this thing emission friendly and road legal. And so they want it to be efficient in all operating conditions. They want it to be able to meet emission regulations. And that is why they changed the cylinder head design on this engine. So they now have tumble flow intake ports. So whereas previously you have that air coming in, it kind of arcs in at a decent angle there, wraps around that intake valve and then dumps within your combustion chamber. Now you have a kind of a changed pathway where you send that air in, it goes over the top of that intake valve, hits the other side, and then tumbles in there. So you're kind of creating a restriction in order to speed up that airflow and create this turbulent circle tumbling airflow right here, which causes the air and fuel to mix really well. And so at low RPM and low load conditions, this really helps out with efficiency. And so that's why this is done. And so, yes, this may be better from a resistance standpoint for creating horsepower, but this will enable this thing to, keep the internal combustion engine alive, and then you can compensate for the fact that perhaps you've made it more restrictive for that air to enter in. Well, you can compensate with this with boost, of course, using fuels like E85, things like that. So there are ways to increase power and still allow for features like better efficiency at low RPM and low load so that you keep this engine chugging along. Using that tumble flow intake port also helps with cold starts, so you have better mixing of the air and fuel, and you don't have to have quite as rich of a mixture on cold startup in order to have consistent, easy combustion. Now, another fascinating change with this engine is that they've switched from a cross-plane crankshaft in the Agera over to a flat plane crankshaft here in the Jesko. And so I have a couple videos explaining this in detail and the advantages of each, but we're going to get a little bit into Koenigsegg specific scenario here. So a cross-plane crankshaft, meaning your crank pins are 90 degrees apart. So with 4 separate crank pins, one crank pin for every 2 cylinders, you'll have one, it rotates 90 degrees, you'll have another after rotating 90 degrees, another after rotating 90 degrees, and then you've got your 4 there. And so with a flat plane crankshaft, you rotate those crank pins instead of 90 degrees like with the cross plane, it is 180 degrees. So instead of it making like a plus sign, if you were to look down, it's just a straight line. And so there's advantages to either scenario. With this cross plane crankshaft, they're generally smoother. You can balance out the first order vibrations with heavy counterweights. So the disadvantage is that it's going to have a heavy crankshaft, but it's going to be smooth as a result. The secondary forces are balanced out. Again, I explain all this in more detail in some other videos included in the video description. Versus the 180 degree, the flat plane crankshaft, the primary forces are balanced out, so you have a lighter crankshaft overall, but the secondary forces are not. And so it does actually have more vibration as a result. So you're able to get away with a lighter crankshaft and you're able to rev it up higher, but you tend to have more vibration. So in Koenigsegg's example, they're able to increase red line from 8250 up to 8500 RPM here with the Jesko. So very cool. And they claim that they have the lightest crankshaft for a V8 engine in production. So just 12.5 kilograms for the crankshaft's weight. Very cool there that they've been able to keep that weight so low. And one of the reasons they were able to do this and still get away with, not annoying the driver with those vibrations is that they have active engine mounts. And so those active engine mounts, they actually used on the Regera. They did not on the Agera RS. So when switching over to this engine, they are able to tolerate a bit more vibration with those active engine mounts to compensate so that the driver isn't annoyed by the engine vibration. And of course, an additional benefit of doing this is that you even out those exhaust pulses, which allows for better scavenging. Now, if you have an engine that's making so much power, over 300 horsepower per liter when running on E85, well, you're gonna need giant turbos. So the engine just has 2 turbos, and that means just 1 turbo per cylinder bank, which means if you wanna hit those huge boost numbers, create tons of power, well, you're gonna need giant turbos. Now, the unfortunate story is that giant turbos mean that you're going to have a high boost threshold, meaning it's going to take a certain RPM with a certain amount of exhaust flow to actually get those turbos to start spooling, and you're also going to have a lot of turbo lag. So when you put your foot down asking for power, and then it takes a while for those turbochargers to spool up, that lag can be annoying for the driver. It's a downside. You don't want turbo lag or these high boost thresholds. And yet Koenigsegg is somehow able to hit 1,000 Newton meters of torque at just 2,700 RPM. So what do they do? So it's a very cool system. It's actually somewhat similar to what Volvo has done with a diesel engine, where they have a 20-liter carbon fiber tank that has 20 bar pressure in it, or about 290 psi of pressure. So there's an electric air compressor that's compressing air and storing it in this carbon fiber tank. So let's say you're at 2,700 RPM and you put your foot down, you want lots of power. Well, what's going to happen is your turbocharger is way too big. It's not able to spool up. So what do? Well, they take this compressed air, this 20 bar pressurized air, and they dump that into the exhaust there to spool up that turbocharger to help spool up the compressor side, and then pull in air and give your engine plenty of boost very quickly. So it eliminates both problems. It means you can have boost at lower RPM, and it gets rid of your turbo lag. So a very cool solution. And also, there are different ways of doing this. So Koenigsegg looked at a few different options. They said, we could use quad turbo. It could have 4 turbos or 3 turbos. You have a smaller one that spools up first, and then you use a larger turbo. The reason why they ended up going with this system here is that it weighed less. So they said this entire system, carbon fiber tank, electric air compressor, weighs about 7 to 8 kilograms, versus if they were to go with multiple turbos, they'd be at least about 25 to 30 kilograms. So a lighter system, and it solves their problem with the boost threshold and with the boost lag, the lag in having that turbocharge spool up. So very neat, the implementation of that system. And also, it kind of serves a dual purpose. So this is also another benefit of using this system. Of course, they want this engine to be emissions friendly. And one of the big problems with emissions is cold startup. So that's when your catalytic converter is not yet heated up. It's not performing the proper reactions in order to prevent harmful gases from escaping out the exhaust. So you need to have that catalytic converter warm up very quickly. So there's multiple things they do here. One of them being injecting air into the exhaust there, and that helps to speed up the process of heating up this catalytic converter. So there's a couple ways that happens. First of all, by injecting that air into the exhaust, you're introducing oxygen into the exhaust. If there's any fuel remaining, that means you can burn that air and fuel before it reaches the catalytic converter and help heat it up that way. It also means you're providing oxygen for the catalytic converter, which can use that oxygen for oxidation reactions within the catalytic converter, which create heat. On top of all of this, they have an electric heater within the catalytic converter to also help warm it up once you're starting the car. And finally, we get to pressure sensors. So this is the last feature we'll be discussing. Very cool. They have a sensor which is measuring the pressure inside the cylinder, and they claim that they're the first ones to get this to market in a production vehicle. So this is also being done in Mazda's Skyactiv X engine, but of course that is not yet in production. So they're claiming they're the first to the market with this. Very cool technology. And why would you want to do this? Why would you want to measure pressure, and how does that help you in any way? Well, if you look at a graph of pressure versus time for your power stroke. So you've got that compression stroke coming up, it's pressurizing that air, you see pressure start to rise, and then you fire your spark plug. And once you fire your spark plug, your piston starts to move down, that flame expands, and you have this peak in pressure. And so you want that peak in pressure to occur at the exact moment that gives you the maximum amount of work pushing that piston down. And so there's a delay in time between when you fire the spark plug and when you reach that peak pressure. And that delay in time changes. It's not a constant interval. And so by having a pressure sensor, you're able to constantly monitor both of those things. So the ECU is getting that information. It's getting when did the spark fire and when did peak pressure occur. And it can adjust when it should fire the spark in order to optimize where that peak pressure should occur. Of course, you don't want peak pressure occurring before top dead center. That means you're pushing the piston down when it's on its way up. You don't want it occurring too late, because if the piston's all the way down here, then you're not getting that much useful work at it, versus if you were to have that occur at the very top and push it all the way down with that peak pressure. So it's very critical when peak pressure occurs, and you're able to optimize that using a pressure sensor and then changing when do you fire the spark plug in order for that to be at the perfect time. So it's great for efficiency and it's great for power, both of which they are going for with this engine. Quite a neat design. I've probably said it's cool like 1,000 times in this video. I hope you all enjoyed watching. Thank you so much for watching. And if you have any questions or comments, of course, feel free to leave those below.